Welcome back. We're going to take a look at using rigid bodies in code now. So the first video, we did make use of them to sort of apply gravity and bounce things around, but we haven't coded anything with them yet. And there's quite a lot you can do with them. So using a similar setup to last time, we've still got the cube, but in terms of code, I've actually stripped all the code out with the exception of the update function. While it was nice, it wasn't something we're going to use in the future. It was purely for the sake of understanding how input works. So yeah, if you want to strip it away or save it as a different file, whatever, make sure as well that your cube has a rigid body attached, which currently it does not. So go to Add Component and Physics Rigid Body, or you can search for rigid body. So we've got a rigid body attached, and we've got this code component attached, so let's jump into it. And rigid body works slightly different to the way we've been working with the transform so far. The thing with the transform is that every game object will have a transform component, so we can just access it through transform like that. And rigid body used to work that way, but they've done away with it. So it used to be that you could type rigid body in lowercase and access the rigid body. But you can't guarantee that every object's going to have a rigid body. So they've done away with it. It will still try to fix itself if you've got script that does that, but it's not good to get in the habit of relying on it fixing problems. Let's just do it right the first time. So instead of using Unity's built-in reference to the rigid body, we're going to make one of our own. And to do that, we'll use a variable. So outside of this update function, we're going to make a variable that we'll keep it private. There's no reason for it to be visible outside of the code. And we'll give it a type. It's going to be a rigid body, and then we give it a name. So you might just want to call it rigid body. If you follow Unity's tutorials, they actually use RB, so we could go with that just to keep it consistent with theirs. So private rigid body RB. There is our variable. Currently holds nothing. So what we'll do is make use of the start function. So we'll reinstate the start function to grab hold of the rigid body and store it in this variable. So in the start function we'll do RB because we're going to set that variable equals, and here's something new. This is where we need to fish for a component in our game object, and we're going to use the get component function. So get component, and then we use triangle brackets or angle brackets to tell it what sort of component we're looking for. And in this instance it's a rigid body. So we want to find a rigid body, and then because it's function, we have normal brackets as well. Close the line with a semicolon and save it up. Now, there is a chance that you've put this component onto an object that doesn't have a rigid body, in which case this get component rigid body would return null, and null means nothing. So for future reference, it might be worth checking every now and then that the rigid body is actually there. So you could use something like if brackets rigid body RB equals equals. So equals asks rather than sets. So on this line we've said that rigid body or RB equals something. Here we're asking if it equals something, so we use two equal signs. So if it equals null, we could do debug.log no rigid body. And just for the sake of seeing if that bit of code works, let's temporarily get rid of this rigid body. Oops. Got a problem somewhere. I didn't put a semicolon. Let's just get rid of the rigid body from our cube. So we'll click the cog and we'll remove it. Test it. And you can see that we've popped up a little message saying no rigid body. Just undo it so we get the rigid body back. There we go. Run it again. And we don't get the message. So we can assume that our code has picked up the rigid body and it's now stored in this variable. I'm actually going to get rid of that just to keep the code a bit more lightweight. Now in the update function, we can actually make use of this rigid body. But to do what? Who knows? We'll start by just checking on its condition. Rigid bodies, when they're in action, if we have a look at it here, if I just drag it up in the air a little bit, got a warning saying we've not used our rigid body yet, don't worry about it. Drag it up in the air and hit play. and it will fall. And while it's falling, this rigid body is considered awake. And now that it's landed, after all the forces applied to it have settled and it's come to a complete rest, it goes to sleep. So rigid bodies sleep, and it's sort of saves on performance. They don't have to do as many calculations on sleeping rigid bodies. And we can query that. So in the update here, let's just put if brackets rb dot is sleeping, and this is a function, so it needs brackets. And we could query this. We could say equals equals true. But the way if statements work is that they will run if the content of this brackets is true anyway. So if the function gives us the word true back, we don't need to ask if true is true. We just don't go with it. If it's sleeping, we're then going to debug .log, and let's put leave me alone. I'm sleeping. Close the if, save it up, and give it a try. So hit play, the block will fall, and then it's gone to sleep and starts spamming us. Let's just make sure that wasn't a fluke and that it was actually spamming it all along with a bit of lag by rotating the plane so that when it lands, it actually rolls a little bit before it stops. Stop. No. So it never fell to sleep there. We never got the message. It rolled a bit too far. So let's maybe level it off a little bit. Go on. Yeah. So it stops and then we get the spam. And we get a bit sick from the camera following it. So that worked. Let's just reset this plane. Okay. Let's take it a step further. Instead of just saying it's asleep, let's thrust it back up in the air when it falls asleep. So let's get rid of that message and let's do rb.apply, add force. Let's add a force, and then in brackets we are prompted for some information. It's got 4 possible options, so let's just scroll through them. First we could add a vector 3 of force. Let's not. No. Let's do this one, so we can deal with 3 numbers again, because we're used to doing that by now. We don't want this to go side to side. Let's put 0. We do want it to go up in the air though, so let's give it a big upwards force. Maybe go 10 for now. Let's see what that does. And then Z, let's not bother. So 0, 10, 0, and let's give that a go. So it should drop, fall asleep, and then shoot back up, hopefully. 10's obviously not quite strong enough. So let's maybe put it to 100. So it's getting a little hop. Still not quite strong enough. Let's times that by 10. Let's go for it for the 1,000. Whee! And what it means now is that this poor rigid body now never gets any rest. As soon as it falls asleep, we send it leaping again. But it might be quite a good idea for a bad guy. So it's like an inverse thwomp from Mario. Instead of falling down and then slowly trickling back up, it leaps up here. Kind of like the lava bubbles do. Sorry, I've been playing Mario Maker, so it's on my mind. But yeah, there's how we can add force to this rigid body. And just before I swap to a sphere, so we're going to use a sphere and control it and roll around, very similar to the way the Unity tutorial goes. I just want to look at an extra little bit of something we can do here. So we're going to do something similar to this get component, but this time we're going to do it with the renderer, and we're going to use it to change the color of our object. So up at the top, let's make another variable. Let's make a private renderer, and we'll call it ren. So we've made another variable. It's going to be a renderer, and it's called ren. And we're going to do the exact same thing in start here, where we go ren equals get component. I don't know why I was doing a dot. Get component, and then in the triangle brackets, it's a renderer this time. End function, and we now have access to the renderer. And what we're going to do straight away is to set the renderer's color. So we'll do ren dot material dot color, and it uses American spelling here, equals, and then we can just use the color class built into Unity, and select one of the presets. So let's maybe have it green when it spawns. And then down here, when we fall asleep, instead of adding a force, we can add a force as well, I suppose, but just instead I'm going to change the colour to something different. So ren.material.colour equals colour.blue. So it's going to drop from the sky and it should be green, and when it falls asleep it'll turn blue. There we go. Now got a bit of colour to the scene, and we can clearly see the state of that rigid body as it's in motion. Okay, maybe one more thing I suppose, while we're in this cube, just to keep it centralised. We can actually detect when things happen here, so we can detect when it hits something. With a rigid body, with any 3D object really, we can see when it's bashed into something. And what's quite useful to see what other things you can do is to make use of the help. So as we did very early in the code, we selected a word and we did command or control apostrophe, and it took us to the Unity help. In mono behavior, you've got a big list of things known as messages, and in there you will see a couple that we've used already. So if we scroll down past all the on things, we've got start and update, and we've been using those quite a lot. But we've also got a massive wealth of other things, and the one I'm looking for at the moment is on collide, or on collision, sorry. Here we go, on collision enter, we've got on collision stay, and we've got on collision exit, and they're useful for when things start a bit of contact, when the contact is maintained, and when the contact ends. We could make use of all of them. So I'm actually going to use this on collision enter to detect when the cube hits something. In this case it'll be the floor. So I've clicked on it, takes us to the help, and we can see how it's used. So we've got an example here of this object playing a sound, is it? It's got an audio component, so I'm assuming so. Yeah, so it plays the sound if it's a big hit. We're not going to get that, in fact, that advanced. I'm really just after this line. So I'm going to copy that, steal it from their docs, and go to my own code and paste it in. So now we've got a new function, and it's called onCollisionEnter. And there is a big difference now with this, with the addition of some information in the brackets that we've not seen before. So start doesn't have any information in the brackets, neither does update. But onCollisionEnter needs some additional information, and it takes a collision. And what this actually refers to is the other object. So a better name, a more commonly seen name as well, is to use other there instead of collision. So that's going to be a collision into the other, or it's a bit of information about the collision. So really, collision was fine. Other just is a mental reference that we can access the other object. So we could put here ren.material equal, ren.material.color equals color.red. So when we hit something for the first time, when the collision starts, we're going to turn red, and then eventually we'll fall asleep and turn blue. So we should see 3 colours now. Let's save that. Back to Unity, hit play. It should fall as green, turn red when it lands, and then after a brief time when all the forces have died out, it goes blue, which is pretty cool. Maybe to keep the red for a bit longer, let's put some of that rotation back. Hit play. Turns red, rolls a little bit, falls asleep, goes blue. Good stuff. And what all that collision stuff is very handy for is game logic. So here we might decide that if we've bashed into a baddie, we kill the player. We're not at that point just yet, but just for future reference, it's well worth noting that onCollisionEnter is useful to see what you've hit into. You can check, using this extra bit of information, you can see what you hit. So let's just quickly put debug.log, and we'll do other.gameObject.name. So that's going to get the other game object's name. So in this case, it should be that we bump into plane. So it should debug.log plane. Let's give it a try. When we land, check the console, and we've got plane because we bumped into an object called plane. And I'm sure you can imagine ways of using if. So if other.gameObject.name equals plane, do something. And that's how we eventually turn that into gameplay. And we are going to do that later on. I just don't want to dwell on it for now. What I do want to do is make another object. So I'm actually going to, in my hierarchy, bring my main camera out of that cube. I don't want it following it around anymore. And I'm going to add a new sphere. This sphere is going to be our new playable object. So it's going to need some code. Let's make a new C# script. Let's call it sphere controller. And fire it up. And in here, we want to do very similar to the way we did with the cube. We want to store the rigid body. So let's make a private rigid body called RB. Let's get rid of the comments. And in the start, let's populate that. So RB equals get component rigid body. And that will do there. And then in the update, we can make use of it combined with our newfound input skills to apply a force based on the horizontal and vertical axis from the input manager. So let's do rb.add force, and then in brackets, let's make use of x, y, and z. We're not going to be using any y force. We don't want to thrust it in the air, but we do want to move in the x and the z. In the x-axis, I want to do input.getAxis horizontal. And that's just ripped straight from the last video where we moved our cube around. Then we want 0 movement, 0 force in the y-axis, and we want input.getAxis vertical for the z-axis, so forwards and backwards. Make sure all your brackets are closed up. And there we go, one line that does so much it's almost unfair to other ways of making games. So let's save it. Let's make sure that the code's attached to our sphere and that we have a rigid body on the sphere. Hit play. And, oh, camera's not actually in view of anything. Let's just drop it down a little bit. There we go. And using the arrow keys, I can now roll that sphere around. And notice, because the cube's still processing collisions, it briefly flicks red when we first bash into it, which wakes it up, so it doesn't go instantly blue, but then eventually it sleeps again. It gets bored and goes back to sleep. Now this sphere movement is painfully slow, so let's speed it up a bit, and we'll actually have a bigger impact on that cube when we bash into it. So let's just multiply these forces by 5. And there is an extra little issue that I want to go through with physics, and it's to do with the way we're structuring our functions, or the way we're picking our functions at least. So we've got a bit more speed now. Let's try and build some speed up and crunch into this cube. See if we can knock it over. I just grazed it because I'm a bit thick. Oh, I'm useless at this game. Let's make this plane bigger. Whoop. I'm not going to fall off the edge. Right, so let's move over here, get a bit of a run up at it, and it nearly moved, so we could make those 5s much bigger. But we can see it's working. We've got a sphere rolling around affected by physics, and we've got this cube in the middle being recoloured based on the state of its rigid body, so that's all good. That's progress. What I do want to just raise your awareness of is this choice of function. What I mentioned very early on in the set of videos is that update happens once a frame, and that's actually at the discretion of the computer. It's how fast it can afford to update, to redraw everything. So different computers call that at different speeds. However, Unity's physics engine needs to be more consistent, so there's a different function we can use here, and it was in this list when we were looking at messages. It's fixed update. So this function is called every fixed frame rate frame. So it's basically the physics update of the game. So in our code, instead of using update, if we used fixed update, it's a much more consistent approach. That would be the same across every version of our game. Now, let's see what effect it actually has, because my computer, with it making the video, it might be that my fixed update is actually happening a lot faster than my normal update, so that might automatically make the impact a bit more impressive. It doesn't seem, it seems fairly consistent. Bosh. No. But just for future reference, anything to do with physics, you should probably be using fixed update. Visual stuff or just general checking, you can go in the update, but from now on, whenever we do something physics based, I'm going to throw it in the fixed update. And for now, I think we will leave it at that. We're very, very close to having enough to make a game now. So it's probably 1 or 2 more videos and we can do a little game.